Hi guys, I'm Farda and today we will be looking at significant figure. So let's jump to this question here. We have 5.3 multiply with 4.28, and when you plug this in into the calculator, you'll get 22.684. And when we see all those answers A, B, C, D, all of them look like the same, aren't they? But which will be the final answer? Or to be exact, which one will be the answer to the correct sig fig? So those who gonna need a minute, you can pause the video, and those who already have the answer, very good. So the answer is 23. And to really understand how we get this answer, you guys gotta check out the rest of the video. And for those who get this right from the very beginning and probably did not take you much time, you can just jump to the rules for the addition and subtraction and also the antilog and log. So we're going to start with the rules of significant figures. So we have 5 significant figures rules. Means, how do we know that a number contains how many significant figures? So the first rule says that all non-zeros numbers are significant. Means what? Let's say you have 432.55. So we do not see any zeros number here, right? So all of this are significant. That means we have 1, 2, 3, 4, and 5 significant number here. So we have 5 sig fig. And the zeros between the regular numbers are significant. That means if we have 5015, the zeros in the middle of this regular number, they are significant too. So our significant figure in this case are 1, 2, 3, 4. So we have 4 sig fig. The zeros at the beginning of numbers are not significant. So we have, let's say we have 0.00543221. So guess how many sig fig do we have? So as we can see, we have 5, 4, 3, and 2, and 1. That means we have 5 significant figure. And these 3 zeros in the beginning, they are not significant. Number 4, zeros at the end of number are significant if they contain decimal point. So if we look at the zeros at the end, let's say we have 53.210. So we have zeros at the end here, but to know whether this is significant or not, we gotta check if there is decimal or no decimal. So in this case, we have a decimal. So when we have decimal, the zero at the end is significant. Let's say the same number, but let's remove the decimal. So we put 53210. So the end 0 is not significant. So in this case, we only have 4 sig fig. While on the previous question, we have 5 sig fig. I hope you guys understand the rules for the significant figure. Now let's try these questions. So we have 3.0800. So how many sig fig? So we know that we have zeros in the middle. So this 0 is sig fig, but now the question is at the end 0, are they significant or not? And we know the zeros at the end, they are significant if they contain decimal. So in this case, we have decimal there. So the number of sig fig here are 1, 2, 3, 4, 5. So we have 5 sig fig. Number B, the zeros in the beginning. So we know zeros in the beginning of normal numbers, they are not significant. So this one are not significant. So we only have 3 significant figure. C, that's a good question there, right? If we have a multiplier of 10 to the power of whatever, these are never counted in the significant figure. So we're going to ignore this. And let's look at this number. So we have zeros in the middle, which is significant. So this is just having 3 significant figure. Number D, we have zeros at the end and there is no decimal point. So that is not significant. So these zeros are not significant. So we only have 2 significant numbers. And E, that's a good question there because we have a point at the end. This is not a typing mistake there. There is a decimal at the end of the zeros. So we're going to count the zeros here as significant too. Therefore, we have total of 4 significant figure. And at the end, we have 0 at the end, and there is no decimal, so we only have 1 significant figure. I hope you understand how to figure out how many significant figures are there in numbers. Now, we want to see how do we round off the numbers to the correct significant figure. So before we even start rounding off, we want to see how many significant figure we have. So in this case, we have 1, 2, 3, 4, because the zeros in the beginnings are not significant. So we have 4 significant figure and we want to round it off to 3. So that means we're going to stop at the 3 here, right? And because after the 3, the number is less than 5, so we keep the 3 as it is. So the correct answer will be 0.00983. In the next question, we will see how many significant figure we have. So we have 1, 2, 3, 4, 5. The zeros in the beginnings are not significant. So we have 5 significant figure and we want to bring it down to 4. So we stop at here, the 1 here. But let's look at the what number after the 1 to the right. And that is 8. Whenever it's more than 5 or more than 5, we add 1 to the previous one. So now we have 0.03242. Let's look at the next one. So as we know, the multipliers, they are not significant, like we do not care about them. So we just look at this, and this has 3 significant figure and we want to round it up to 2 significant figure. So what we have to do, we stop it at here and we say that it is 5 or more, so we add 1 to it. So what is 9 plus 1? It's 10, right? So it's actually going to be 8.0 times 10 to the power of negative 5. And remember how the zeros at the end are significant when we have decimal. So this is actually 2 significant figure. The next one, we have 9100, which is 2 significant figure. Zeros at the end are not significant and we want to bring it to 1 significant figure. So we stop here. This one, we make it 0. So it's going to become 9,000. So the next one, we have 1, 2, 3, 4 significant figure because we have a decimal there. And we want to bring it to 2 significant figures. So what do? We stop at here. And after 5, there is a 6, which is 5 or more. So we bring it to 7, 6, and the rest we put zeros. And we do not put the decimal point because if we somehow put a decimal point here, that's going to make it 4. But without the decimal, the zeros are not significant. The next one, we have 3, we actually have 4 significant figure and we want to bring it to 3. So we stop it at here and we get 1, 3, 0, 0, 0. But the problem, this is a what? This is actually a 2 sig fig. So how do we bring this to 3? Right? We can make it in scientific notation. We can make it 1.30 times 10 to the power of 4. So that is a 3 significant figure. Now, how do we apply the significant figures in calculation? So the first one is addition and subtraction. And in this case, we actually do not look at the significant figure. Instead, we look at the number of decimal places. Means what? The number after the decimal point. So in this case, in the first one, we have, this is the decimal point, and to the right, we have 4 numbers. So 1, 2, 3, 4. We have 4 decimal place. In the second one, we have 2 decimal place. And in this one, we have 1 decimal place. When we add all these numbers, we're going to get 3.974 as the numbers in our calculator. But what do we put as our final answer? Our final answer will have 1 decimal place because when we are in addition or subtraction, we actually look at the decimal place. So we're going to have 1 decimal place. Means the final answer will be So we're supposed to stop here, right? Because that is 1 decimal place until the 9. Now, because after the 9 we have a 7, that's going to be added to 1, which makes it 4.0. Now, what about the rules in multiplication and division, right? So in multiplication and division, we multiply everything, we divide everything, and the answer is supposed to be the lowest significant figure. Now, it's not based on the decimal place anymore. Decimal place was just in the addition or subtraction or both. But when we have multiplication or division, we look at the lowest significant figure. So in this case, this has 3 sig fig, this has 4 sig fig, this is 3, and this is 2. And the lowest one is a 2 sig fig. So we're going to make this answer to be to 2 significant figure. So we're going to stop at here. We have, and after the 7, it's a 1. So we make it the same way. We keep the 7 as 7. In logarithm, we have different rules. So this is something that is very least talked about, but we're gonna need this in calculation of the pH. So the way we're going to do this is first, whenever we do the logarithm, right, the numbers that is given to us, we're going to look for total significant figure. So in this case, we have 4 significant figure. When we put this into the calculator, we're going to get this whole long answer. So what do? We're going to keep the number of same significant figure, but now just after the decimal. What do I mean by this? So let's look at this. So here we have 4 significant figure. So in this case, we're going to keep 4 after the decimal. 4 significant after the decimal. So we have 1, 2, 3, 4. So we stop here. And then after the 0 is 5. So we're going to make 0.6021. Let's see another example. So here we have 3 significant figure, right? So we are supposed to have 3 significant figure after the decimal as the answer, after the decimal. So that means we have that. We stop at the 3. After the 3 is a 2, which is less than 5. We keep it as it is, which is 1.623. This one has just 2 significant figures, so we put 2 after the decimal, even though the 3 is significant, but we just look at after the decimal, so we stop here. The answer would be negative 3.28. We have 2 significant figure there, so after the decimal, we're going to keep 2. We're going to stop there. The answer would be 2.18 because we have a 6 after the 7. So anti-logarithm would be the exact opposite. In the anti-log, so how do we find anti-log, right? So when they say anti-log of that, that means it's just 10 to the power of 0.0334. So that is what we mean by anti-log. When we find this, we're going to get the answer to be this, but into how many sig fig do we keep, right? So the answer supposed to have the same number of sig fig as the 1 after the decimal. So after this decimal here, how many sig fig we have? We have 3. So we're going to keep 3 sig fig here. That means this answer would be 1.08. The anti-log of 4.93 going to give us this. And after the decimal, we have 2 sig fig. So the answer is supposed to have 2 sig fig. So we're going to keep it until 5. So 8, 5, the rest we're going to put zeros. Never ever just remove the zeros or remove the 114 totally off, because what's going to happen, you're going to have 85. And that's going to be wrong. That's super different from the 85,000. Instead, we plug all these numbers to be 0. The anti-log of 0.5 going to give us that. And after decimal, we have 1. So we're just going to keep 1. So it's going to be just 3. Here we have after decimal 2, so we're going to keep 2 here. So this is going to give us 1.0. So I'm going to leave you guys with this question. Comment down below what is the answer that you get to the correct significant figure. Thanks for watching. I really appreciate it. Thank you. If you liked the video, please subscribe and don't forget to like. Thank you.